All right, we're looking at the Blake Levine case study now. Let's scroll down and read the first question. Question 1. The minimum value of the convertible bond on September 15th, 2014 is closest to. We've got three numbers here. So before we dive into the reading, minimum value of the convertible bond is always going to be the greater of either the value of it as a straight bond. So convertible bond, we're still going to be receiving our par value at maturity and getting some type of cash flows or coupon paid over time. So we need to find the value of that. And then we also need to find the value of it if we were to convert it. And if the conversion value is greater than the straight value, then that tells us, then that value will be our minimum value. But somebody is always going to be willing to pay whatever either the greater of those two is. All right, so on the morning of 15th September 2014, Blake Levine, a fixed income investment analyst, is asked by his supervisor, Natalie Jonas, to analyze a convertible bond issued by Viridian Pharmaceuticals. Levine immediately gathers the relevant data from the convertible bonds offerings circular shown below in Exhibit 1. So we've got issue date, maturity date, so it's a 5-year bond, and we have 4 years. We have 4 years left to maturity since it was issued exactly 1 year ago. And then let's see. So then coupon, this is going to be important for the straight, calculating the value of the straight bond. So we're getting a 4% coupon. So did it say how much we bought here? So we bought bonds denominated in 100,000. So we're going to be getting 4% of 100,000. That's going to be our coupon, so $4,000 per year. We've got conversion period, initial conversion price, conversion ratio, threshold dividend, and change of control conversion price. Okay. And then let's scroll down here because what we're going to need for conversion value is not included in here. We're going to need the market price, but then we will use the conversion ratio. So we haven't gotten to the market price yet, so let's keep reading. While gathering the market data shown below in Exhibit 2, Levine learns that VDP also issued an option-free bond on 15 September that was otherwise equivalent to the convertible bond, and that the company's common stock was trading at $4.25 per share on the day these bonds were issued. Okay, so this is a little tricky because we do need to use this VDP share price, but we're not going to be using anything else in here. We're going to be using the convertible bond information up here since we're looking at the convertible bond, not the option-free bond. So let's bring in this information here. I think I can fit it right there. Okay, so we're going to be converting the conversion value, which is going to be market price of the common stock, that 5.25 number, multiply that by the conversion ratio, which we're given is 20,000 shares. That gives us a value of 105. And then the straight value of the bond is just going to be those coupons plus par discounted back. So we've got 4 years worth of coupons since we have 4 years to maturity. Then $100,000, we're discounting that back. It gets us to 105,643. So we take the greater of these two values. So we're gonna, our minimum value is going to be 105,643. Answer B. Question 2. The market conversion price on 15 September 2014 is closest to 525, 605, or 630. So conversion price, that formula is going to be our convertible bond price. So our convertible bond price in this situation is going to be this 121 number, which we have in Exhibit 2, which is where we left off last question. And then we need the conversion ratio number as well, which is going to be given up here in Exhibit 1. So we need to do a little digging back here at 20,000. So this will be pretty straightforward. We'll have convertible bond price over the conversion ratio, which gives us 121 over 20 and 605 as that answer, which gives us B. Question 3. On September 15th, 2014, the premium at which VDP's convertible bond is trading over the otherwise equivalent option-free bond is closest to. So For this question, we've read through Exhibit 2 already, which has all the information we're going to need for this. So basically, we need to just kind of determine this 121,000 number, which is what we're priced at right now. What's the premium of that over the option-free bond? So the option-free bond is going to be basically what we calculated in question 1 of this case as well. So we're going to be discounting those cash flows back. So that 4% coupon, we're going to be discounting that plus the par value back for 4 years, and that's going to give us a straight bond value, and then we're just going to put 121 over that straight bond value, and that's going to give us our answer. So let me pull in the straight value calculation again. So we've got 4,000 for 4 years plus that 100,000, discounting that back by 1.025, which is our interest rate for all maturities right here. And then we're going to compare this to the convertible bond price and subtract out 1. So we've got convertible bond price 121 over this straight bond value of 105,643, and gives us a premium of 14.54%. We'll round that and go with answer A. Question 4. The options positions listed by Levine in response to Jonah's question on September 16, 2014 most likely include. So we've got a few different option positions. They're pretty lengthy answers, so let's go ahead and read this part, go into the reading first to save some time. So we left off just under the exhibit. We'll start here. On September 16, 2014, Jonas asked Levine how to synthetically construct a convertible VDP bond. So to synthetically construct a convertible bond, what we're going to do is we're going to buy a call option on that on VDP, and then we're also going to buy the underlying bond. So that's going to be 2 long positions right off the bat. That is both callable and puttable. So now we have 2 other option legs that we need to add to make it callable and puttable. So we need to look at those features and then decide what position we need to take there. Levine responds that this can be accomplished by combining a long position in an option-free bond. Okay, so we've got that to start with multiple options positions, which he lists. Okay, so one thing, let's look at these answers now. Right off the bat, we've established that we need to be long a call in the stock. So A, we do have long call in the stock. B, we have long call in the stock. C is a long put position in a put option on the underlying bond, and a short position in a call on the stock. So we can rule out C right away. So we need to be long a call on the stock. So then we need to decide how to make this bond callable and puttable. So for a bond to be callable, this protects the issuer. And essentially what's going to happen is for a callable bond, this is going to be if interest rates fall. If interest rates fall, the issuer is going to want to call the bond back so that they can issue debt at a lower rate. So when interest rates fall, that means that prices are increasing. So when prices are increasing, the position that we would need to have our bond basically called away is to write what's called a covered call on the bond. So if we go short a call on that bond, let's say the price is at 100 and then we write a call at 105. If interest rates fall and that bond price increases, we're going to have our bond shares called away at 105. So that's the second leg that's going to make this callable. So the second leg, we've got a long position in a call option on the underlying option-free bond. So that's going to lead us to rule out A. Let's make sure B looks good. And then we have a short position in a call on the underlying option-free bond. So this looks like B is going to be our answer. So then let's look at puttable just to make sure this last part makes sense. So to make the bond puttable, this is going to be a benefit for the issuer. So, or not for the issuer, sorry, for the buyer of the bond or the debt holder. So if I buy a bond with a put option that's puttable, essentially that's a put option where if the price decreases, I'm going to be able to put my bond back to the company, to the issuer. And then, so what happens here is it's the opposite of callable. So in this situation, we're protecting ourselves from an interest rate increase. So if interest rates increase, that's going to cause our price of the bond to go down. And then that's when our call option on the put would come into play. So we could exercise our put send the debt back to the company, and then reinvest the proceeds into the higher interest rate debt. So to make a bond puttable, this is a long answer, sorry, we need to be long a put, and we see that is our third leg here. So we're long a put position, long a put option on the underlying option-free bond. And we're also long a put in answer A as well. But that long call and short call is where the difference is. So long-winded answer, but we come to B.